Welcome, and today I'm going to be looking at a system called nowRail that I've been working on over the last few months. This is a system to control model railways, and the goal of the system was to get rid of wiring. I hate layout wiring, especially when it starts to go between baseboards. So let's have a quick look on the video camera and I'll sort of show you the sort of thing that I'm talking about. So I've been building model railways for a long time. I dread to think how long it is. This is from an old analog layout that I built. And one of the things, obviously, you build your control panel with your push buttons that are then going to activate these sort of snap turnout switches, which is what I was using in those days. And of course, even for a small control panel like this, there was then the need to connect it to the layout. And the way I used to do it was with these multi-pin connectors. Now, the layout that I had in those days, well, like all my layouts, was for an exhibition, and that meant that the baseboards had to come apart, which meant that the wires from here would sort of have to go from here to the first baseboard, these cables as well, and then on to the next baseboard. And let's be honest, every wiring joint you have is a potential disaster. So the nowRail system is a way of cutting out a lot of this wiring. Now, some of you may say, well, if he'd used DCC, it would be easier. Well, I do use DCC. So when I started with DCC, I was sold with the idea that it was two wires to the track. Yeah, I'm not sure about that. This is a NCE Snap-It controller, and I bought a load of these in the early days, connected them all up, and by the time I'd connected them all up, it had sucked all the power out of my DCC controller, because there's no sort of independent, no way of adding a separate power supply. So then you finish up with units like this, where you've got your, one of these is, I think that's the track supply. This is the, just a sort of a 12 volts or whatever input to give the extra power that these connectors then sort of all join in here. Because the problem is then I'm just getting more and more wiring, and my attitude has become lately, why do I need all this wiring? Could I not just do this with the single 5 volts? And that is how the nowRail system came about. Now, a lot of the tutorials and videos I use are about using the Arduino and programming using the Arduino IDE. Unfortunately, the basic Arduino, this is an Uno, wasn't suitable for the job that I wanted because it doesn't have any form of Wi-Fi built in. Now, you can get Wi-Fi modules, and you can get a newer version with Wi-Fi built in, but I'm going to be blunt with you, they're expensive. So the boards that I'm going to be using for these projects are the ESP32, and I've got an ESP8266D1 Mini. These boards on Amazon at the moment, I can pick them up for about £6.50. I can get them cheaper on eBay or AliExpress, and these boards are about I think they're about £5 at the moment. Now, I've included both of these boards in the code. There is some other boards that I've been testing, but the code has been written and I know it works on these two boards for now. If people want to test other ESP32 or ESP8266 boards, let me know how you get on. It should work on quite a few of them. It certainly does on some of the ones I've done. The great thing about these boards is within this little piece here is a built-in Wi-Fi system, but this Wi-Fi system does not work as a conventional Wi-Fi system works. So if we think about conventional Wi-Fi, you have your router box as you have, in your house for your internet, and then you have your connection out to the world. And as you know, when you connect a device, you've got to sort of just connect through to the address of the router box. The problem is with all of this, I did not want more wiring. You know, when I'm taking a layout to an exhibition, the last thing I want to be dragging along is a router box, and I also didn't want to be dragging a computer along. So the system that I'm going to use, although it uses a form of Wi-Fi, it's not using a Wi-Fi that uses a router box. So just imagine it being on the same sort of frequency as your normal Wi-Fi, but without all of this. So this is how esp-now works, and particularly the system I'm using uses a thing called broadcast mode. So this basically fires out a transmission. Imagine it looking a little bit like a text message. It's quite limited in the amount of data that it can send. You know, you're not going to be streaming video over this thing. It sends about, you can send the equivalent of 250 characters, 250 bytes. And it sends this out, and the way I've got it sent out in broadcast mode is it sends this out and all the boards can pick up the same transmission. Now, from a model railway point of view, that means if, let's imagine these two boards here are controlling some lights in a building, this is controlling some points, I can send out a signal from here to say turn the lights off. Both of these boards will receive that message and can turn the lights off as ordered. At the same time, I could send out another message that says turn the points to a different direction. These will get the message, but unless they're told to act on it, only this board will respond to it. And that is the system that I've built, where I've got a system that's sending out these transmissions, and you can basically, a bit like DCC, you can set addresses for things, and the boards with the addresses that have been programmed into them will receive the command and act on it. Now, of course, the nightmare there, I've said that dreaded word, programmed. And one of the things that I wanted to do was make a system that was as open as possible so that those who really know how to program can add features that they want. But also, for the beginner, I wanted it to be very, very simple. So this is a quick sort of schematic of what I was trying to achieve. I wanted to be able to allow users to build their own loco controllers if they want. I'll just swap screens and I'll show you what I'm talking about. So this is one of my DCC controllers. Obviously I can change the functions, I can change the speed, do whatever. And as you can see, there is no wires on this. This is running completely wire free, and it's basically got an ESP32 inside it and a LiPo battery. So that's one of the items that I wanted people to be able to build if they wanted to go to that level. I have got some simpler control designs that I've been working on as well for beginners. Now, going back to our schematic, the other thing that I wanted to be able to do was have accessory controllers. Now, I've already shown you one of my old accessory controllers where it was just using the old sort of push button system to change the points. I've actually designed the system so that those can be transformed into this sort of Wi-Fi system very, very simply, with pretty much limitless amounts of buttons. You know, some of the demos I've been doing, you know, for myself, you could literally put hundreds of buttons on there just by adding some very cheap components and very cheap shift registers. I also wanted to have animation controllers, but as well as sort of the basic ones, let's take a look at a little bit more of a high-tech one. So this is one of my touchscreen accessory controllers. Basically, this has what they call a GT911 touchscreen. It's actually out of a car sat-nav system. You can pick them up for about £6 from AliExpress, and just by pressing on the different buttons I can change the track. These are my traversers, these are obviously my track diagram with my turnouts, but basically it's a high-tech version of one of these old-fashioned panels. And the way I've designed the system, it really doesn't matter which way you want it to go. You can even use the old stud and probe system instead of buttons and really save some money. Now going back to our diagram, as well as obviously the control panels, I use DCC-EX, or it used to be DCC++. That's how I do my DCC train control. All of these items, as well as speaking to the various baseboard controllers down here, also send information to DCC-EX. The reason is I wanted to be able to control conventional DCC accessory decoders, as well as obviously my locos. My traverser is built as a conventional DCC accessory decoder. It works extremely well. I didn't want to reprogram the whole thing. So as these things are sending out their transmissions, not only can they send it to the baseboard controllers, but they can send it to a DCC system as well if required. Now the effects controllers, similar to, I can have items on the baseboards to control lights in buildings. The nowRail system actually has a clock system built into it, so you can actually set the thing that it'll automatically turn lights on and off according to layout time. And then finally, of course, you've got your baseboard controllers. I've just put 6 in here. It's almost limitless what you can put in. Again, how you control your points is really up to you. We'll just look at some of the options that I've tried to program in. Now, on my layout, I'll be honest, I tend to use servos for turnout control. So obviously within the nowRail system, there is a very, very simple way of just adding a servo. I've written the servo control using the PCA 9685 boards. The driver is actually written into the nowRail system, so you don't even have to set these boards up. You basically put in a bit of a line of code that says this is its accessory number, this is the board it's attached to, and these are the sort of angles I want it to turn to when I get a signal. Simple as that. Also, of course, there are the old snap track point controllers. Basically, you energize these things and they go one way, and they require usually a pulse of about half a second. So again, within the system, I've written some code that does send just a pulse of code for those who just need that pulse, so that you can just set the item to whatever you want. Alternatively, you can use the output as an on-off button if you've got something, maybe an animation or building lights, that you want to turn on and off instead. So I've tried to write the system as flexibly as possible. I'm hoping in the future to get some Kato track, because they have a different method, and I will try and do a sort of a Kato track version, because they use, I think the current goes one way and then the current goes the other way, depending on which way you want to turn the points to. So that'll be a feature that I'll look at going forwards. The great thing about the code is anything that you can add doesn't affect the code that's already been written. Now, I mentioned that I control my track and locos using DCC-EX, but I've also written the system so that these different controllers on the baseboards can be controlled through a normal DCC controller. So let's just have a quick look at what I mean. So this is my old NCE power cab. I still keep it around for programming the odd decoder, and by the addition of this little simple circuit, which I will explain a little bit later, what I've decided to do with this video is just do the introduction, and then as I add each component I'll do a separate video. But by adding this little piece into the layout, I'm actually able to take the DCC signal, send it to one of these boards, and then transmit it out to the layout. So it means that even my existing DCC system could be used with the nowRail system, and again I'm able to get rid of wiring. Now, I'm not going to go into a lot of detail about this diagram. This is basically how the software works. So a command is created. This could be from a push button or whatever. It then sends that command over esp-now to one of the receiving units. One of the things the system does do is it sends the command to a repeat buffer. This is in case a transmission doesn't get through. For certain commands, it doesn't send it to the repeat buffer, but for things like turnout commands, it sends it to the repeat buffer so that if it doesn't get a response back within a certain period of time, it sends the command again. I've not found any situations where messages haven't got through, and my current layout with my prototype system doesn't have this in, but I've built it in as a just in case. What tends to happen with things like DCC is instead of repeating it in this sort of method, it would just send out the same transmission 5 times. Sometimes a little bit less, sometimes a bit more, depending on the DCC system. So what happens with this is if the message goes across, when it receives it, it sort of says, yep, I've got this message. It sends a command back just to say, I've got that one, no need to repeat it. Now, one of the issues with the system, and I've done a separate video on using broadcast mode for esp-now, is obviously it is a broadcast. It can be picked up by anyone, and anyone can also send a message to it. Now, the last thing I want if I was at an exhibition was for my layout to be picking up the commands from the next layout. So one of the things that happens within the code is each layout has an address. Now, I'm just going to bring in some code here. Hang on, wrong one. No, it's the right one, wrong screen. So within the code, if I go right to the top, when we start the nowRail system, there are 4 addresses. Think of this as a pin number. These are in hex values, so you could have 00 to FF. If you want to write it in a conventional decimal system, each of these values can be 0 to 255. And when you first start the system up, you enter in this unique code for your layout, and then every one of these messages that is sent and received is checked to see that it has the correct code. If it's got the wrong code, the system just ignores it. It just won't do anything with it. So this is a sort of a basic flow diagram of how the whole works, and again, it's on the Digital Town website. What I've tried to do is write a page that goes with this, and I'll just keep expanding it as I add new features. Now what I'm going to do is show you very quickly just how simple it is, to give you an overview of just how simple it is to add and remove items. So this is a little mock-up that I've made, and this is using the most basic functions within the system. So I've got a ESP32 dev module here, and I've got 3 buttons. So let's look at the code and see how I'm using these buttons. Now, it might seem amazing, but all the code to control those buttons is in these 3 lines. So these are using what I would call an add a standard pin button. That means it's a button that's attached directly to a pin on the ESP32. I've done some with shift registers because obviously there's a limit to the number of pins on the board. But let's just go through this code. So what this is saying is I've connected this particular button to pin 15, and when I press the button, I want it to control accessory number 100, and I want it to send a signal to say 0. Now you'll notice there are 2 zeros. That's because if I press it once, it will send 0. If I press it a second time, it will send 0. This button is always going to send 0. Now I've then got a second button. This one's attached to pin 4, Again, it's going to control accessory 100, and whenever I press this button, first time or second time, it's going to send a signal to accessory 100 to move to its position 1. Usually when you're doing something with DCC, if you want a turnout to go left, you send a 0. If you want it to turn right, you send a 1. So if you can imagine, this is left, this is right, one button for left, one button for right. But one of the things that I've done is some people want systems where they can press the button and each time they press the button it changes direction. So what you can do, I've now got pin 5. This is going to control accessory number 200. When I press the button the first time, it's going to send the 0 command. Press it the second time, it's going to send a 1. So basically if I press it the first time, it's going to turn the turnout one way. Press it again, it'll turn it the other way. Press it again, it'll go back to the first way. And that is literally how simple it is to add the very basic functions within the system. Now I may add some other bits in here later, but I wanted to keep these base functions as simple as possible. So that is literally how the items are added. Now let's see if we can work some magic and watch this happen. So here we have our system. Let's just pull this up a little bit, and what happens, I'm going to press one of the buttons and we see there that that was the button that is commanding accessory number 200. Now you'll notice it sent out a command, instruction number 1 to accessory number 200, direction 1. If I press it again, you get the 0. Now obviously it's sending this message out 5 times. The reason for that is I haven't attached the receiving unit here. So what it's doing is it's sending out the message and it's saying, hey, no one's picked up my message, no one's got it, so I'm going to send this message again to make sure you get it. That's all built in, you don't have to worry about that. One other thing that's built in as well is the button debounce. That's actually built into the code. You do not need to worry about that. All that's taken care of. So that is how, if you like, the transmission works. If we press one of these other buttons, we will see that that's sending the command to 100 to position 0. Press the other button, it's sending to 100 to position 1. So that is how the simplest version of the button commands work. So now what we're going to do is the equivalent for the accessory decoders. Now on my board I've got, rather than using stall motors at the moment, I've just got LEDs in to demonstrate the system as it's working. So you'll see in a minute as we look at the board, I've got an LED on pin 15, 2, 4 and 5. On pin 15 it's for accessory 100, and it will send the when the command is a 0, this one is going to activate, and this value here, 1, means it's going to send a pulse. So rather than turning the pin on and leaving the pin high, it's only going to send a pin for the pin high for half a second, just enough to get the motor to flick across. So on the demo you'll just see the LED come on. Now the reason is you cannot just connect the a point motor directly to one of these boards. You need to put in a relay or a MOSFET, because your stall motor really is going to need 12 volts and preferably be with a bit of a capacitor discharge unit on it to really work well. So you need to put a little bit of circuitry in, and I'll probably do some demos on that later. Obviously pin 2 is the opposite value to pin 15, and then I've done a similar thing on pins 4 and 5 for accessory 200. So here we have our two sketches. We've got the sketch here where we've just added our accessory decoders. On the right I've got the first sketch where we set up the buttons. and I'm just going to press a button now. Let's just bring up the camera. So here we have our two boards. We've got obviously our button board, and then we've got these LEDs that we're going to use to represent the pulses to the point motors. So if I press this button here, I'm not sure if you can quite see it on the camera. You can see those two LEDs pulsing on and off, and we also get a whole load of signals that have come down showing us what's going on. So I'm just going to clear those off, and I'm just going to press one button. Now you'll notice before we were getting 5 versions of everything. That's because we didn't have any receiver unit. So let's have a look at what is now going on here. Let's get rid of the camera. So what has happened is this has sent a command to Accessory 100, and it wants it to move to direction 0. And as we can see over here, it has received that command. Now, once it has received that command, it sent a response back to the first unit to say, I received this command to move 100 to position 0, so you don't need to keep sending me any more commands. So that's basically cancelled any repeats. But as you can see, if we go back to the camera, it's a little bit difficult to see it on the screen, but if I press the buttons, hopefully you can see the LED just pulses on and off for half a second. We're looking at these LEDs here. Let's just do it again. So this pair here. So that pulse is all taken care of within the code. So this is the system working at its most basic method. Now, one thing to be aware of as we're running this at the moment, obviously this is not connected to a DCC system as such. This will work on a DCC layout, but it will also work on an analog layout. As you can see from sort of the hardware setup that we've got here, there is no need for a DCC controller. Obviously, if I want the signals to go to my DCC controller, then I've written some code to do that. But I just wanted to show you that you do not need to be connecting to a DCC system. This will work perfectly well on an analog system. Now, just before I finish this introduction, obviously I showed you how to add the various accessories if they were using the snap type, pulse input point motor. This is how you add servos to the system. So on this one, the PCA 9685 board is just the default 40. I'm plugging it into port 15 on the board. So if you've got one of these boards, you've got 16 positions. This is right at the very end of the board. It's set up to be controlled as accessory decoder number 300, and if a value of 0 is sent, it will move the servo to an angle of 10 degrees. If a command of 1 is received, it will move it to a position of 160 degrees. This is just, again, a standard function just like these that is built into the software, but again it shows you just how easy it is to set up different items to be commanded, and all we would then have to do is maybe add in, we could do a double press version of this one. So let's add, what have we got here? We will put in pin number 4, what have we got? No, we've already used that. We'll put in pin number 2, we'll put 300, 0 on 1. If we now add that to the system, that line will now command that servo. It's as simple as that. So I hope this has sort of given a bit of an overview of what the system does. What I'll now do is a set of tutorials on how to get started and how to use the different functions and sort of document them up one at a time, because to put them in this single video, it'd just go on for forever and a day. So I hope that's useful, and if you want to know more about the nowRail system, it's all free. You know, I'm not charging for this stuff, and it's all open, so if you want to sort of have a look in there and mess around with it yourself, you're welcome to it. But I'll do some more tutorials, so if you sort of click the like and subscribe button, you'll know when the next item comes out.